This video is an introduction to ionic bonds and ionic bonding. Don't know anything about these things, or you feel a little bit rusty? It's no big deal, because we're going to start from scratch. So, ionic bonds are one type of chemical bond. Chemical bonds are like glue that holds atoms together. Okay, like here, two atoms that are bonded together, they're connected, they're glued. Now, ionic bonds are the type of chemical bond that hold together metal atoms with non-metal atoms. Okay, so if you look at a periodic table, there's this big, thick staircase over on this side. And this staircase separates the metals, which are all the elements on this side, from the non-metals, which are most of the elements on this side. So whenever we have a chemical that has a metal connected to a non-metal, that's held together by ionic bonds. So some examples are silver chloride, magnesium iodide, or aluminum oxide. Each one of these chemicals have a metal, this one, or this one from this side of the periodic table, with a non-metal, this one, or this one from this side. So ionic bonds in all of these because there are metals and non-metals connected together. Okay, so now we're going to talk a little bit more about the how and why that's going on with the bonding here, right? It's like, how do these atoms actually connect together? What's holding them? That's what we're going to talk about next. Okay, so to learn more about ionic bonds, we are going to focus on a chemical called sodium chloride. Sodium chloride is a fancy scientific name for table salt. It's the stuff that you put on your food. So sodium chloride is made of two types of atoms. We got sodium. Here's its symbol from the periodic table, and here is a sodium atom right here. And sodium chloride is also made of chlorine or chloride. I'll tell you what the difference between those is in a minute, but you don't have to worry about it right now. And here is here's a chlorine atom. Now, sodium chloride happens when these two atoms come together, when they're glued together by ionic bonds. But the atoms that I have right here, they're not glued together. They're just kicking it over here. They have nothing to do with each other. So I want to talk about what happens to get these separate atoms connected and glued together. Like these, how we go from this to this. I'm going to tell you the kicker. I'm going to tell you the end of the story now so you can follow it through as we talk. The reason why these two atoms are connected is because they end up getting electrical charges. Okay, this atom is going to end up getting a negative charge, and this atom is going to end up getting a positive charge. What do oppositely charged things like to do? They like to attract. And so because these things get different electrical charges, they are going to be held together by those different charges attracting. Okay, so let's look at the steps that we have to take to go from this to this. The first step is pretty much what I got right here. We're starting with two separate atoms that aren't connected. We got the metal atom, the sodium here, and the non-metal atom, the chlorine, over here. Now the first thing that happens on the road to an ionic bond is that the sodium atom gives one of its electrons to the chlorine atom. Here's the electron moving between the two of them from the sodium to the chlorine. Now this electron moving will change the charges of these two atoms. Okay? That's what happens in the next step. Sodium gives away one of its electrons to the chlorine, so it loses one electron. It has one fewer electron, and that's going to give it a positive charge because it lost an electron. But chlorine gained one of the electrons from sodium, so it's going to become negative. It's going to get a negative charge because of that extra electron. So now, these two atoms take on electrical charges. And what do we call atoms that have charges? We call them ions. This one's a positive ion, sodium becomes positive, chlorine becomes negative. Now here's where the difference between chlorine and chloride comes. Chlorine is what we call the chlorine atom when it's neutral. So up here, this non-metal atom, chlorine, just hanging out here, is chlorine, zero charge. But down here, after it's received one of the electrons from sodium, it gets a negative charge, it becomes a negative ion. And now we change its name just a little bit. We call it chloride. So it's the same atom, chlorine and chloride, they're the same atom. It's just chlorine is the version of chlorine with a neutral charge, zero charge, and chloride is the version of chlorine that just has a 1- charge. And it got that 1- charge because sodium gave one of its electrons to chlorine, turning it into the negative chloride. Now people often ask, why does sodium give its electron to chlorine? We'll talk about that in the next video. It's a great question. But anyway, a transfer of electrons takes place between these atoms, giving this one a positive charge and this one a negative charge. And what do opposite charges like to do? They like to stick together. And so this is what we end up with. The two atoms glued together because their opposite charges are holding them together. Okay, so there are really three important steps in ionic bond forming. For the example of sodium chloride, here's what they are. The first step is an electron transfers from sodium to chlorine. Sodium gives one of its electrons to chlorine. Sodium loses an electron, so that gives it a positive charge. This becomes positive. And chlorine, because it has gotten an extra electron, gets a negative charge. And they both turn into ions, atoms with a charge. And since chlorine became negative, we call it chloride. And then the last step after the ions form is that the oppositely charged atoms stick together because of their opposite charges. So it's those opposite charges that form that are the glue holding the atoms together. Okay, So this is just the very basics of how ionic bonds form. We haven't really talked about details, why the electrons move, and that kind of thing. Now, I want to look at why and how these steps happen during the formation of ionic bonds. In order to really understand what's going on in ionic bonding, we have to take a look at the individual electrons that live in sodium and live in chlorine. Now, as you probably know, there are specific places in an atom where electrons can live. Okay, I have a diagram of this here. If this is new, you should check out my video called Valence Electrons and the Periodic Table. Anyway, each one of these little circles represents a spot that an electron can live in an atom. And you'll see that these little electron spots are arranged in rings around the nucleus of the atom. Each one of these rings is called a shell or an energy level. Okay, so we can use this diagram to figure out where the electrons live in sodium and where they live in chlorine. Okay, first thing we got to do is we got to find out how many electrons there are in these two atoms. Okay, now sodium here, you look it up on the periodic table, it's got this 11 here. That means it has an atomic number of 11. There are 11 protons in sodium. Now remember, when ionic bonding starts, these atoms are not yet ions. They don't have a charge. They're neutral. So that means that they have the same number of protons and electrons. So there are 11 protons in a sodium atom. That means there are also 11 electrons in a sodium atom. Okay, the same thing is true with chlorine. It has an atomic number of 17 protons. It's starting out without a charge, so it has 17 protons and 17 electrons. Now, we can take one of these diagrams and fill it in from the center on out with a number of electrons. So for sodium, that's going to look like this, 11 electrons arranged around the atom from the center out. And for chlorine, it's going to look like this, 17 electrons arranged around this from the center out. Now, you may not be able to tell from these diagrams, but these are two very unhappy atoms. The reason why has to do with their valence shells. You remember what valence shells are? They are the furthest out energy level that still has electrons in it. Okay? So for example, this is the valence shell of sodium. It's got one electron here. And this is the valence shell, the furthest out shell for chlorine. Okay? The reason why these two atoms are so pissed off is because every atom wants to have a full valence shell. It's like every atom's goal in life. Sodium is really unhappy because it only has one electron in its valence shell and it has these 7 empty spots. Okay? Chlorine, on the other hand, is also upset because it's got a mostly full valence shell, but it's got one empty spot. It's so close. It's so close, but it's still super unhappy because the valence shell isn't full. So sodium and chlorine are both unhappy. They both want to fix their situation. And in trying to fix it, that is how they're going to end up with an ionic bond. Okay, so how are sodium and chlorine going to get happier? How are they going to fix their situation? How are they going to try to fill their valence shells? Well, take a look at this. They can help each other out, okay? Chlorine has one spot left before it's able to fill its valence shell. And so what happens is sodium can give chlorine one of its electrons, okay? So this electron moves from sodium to chlorine to fill this spot. Here's what we end up with. Okay, let me just show you what's going on here. Okay, so we got sodium, we got chlorine, and this electron up here moves between them. Okay, so it leaves sodium and it goes into chlorine. Okay, and now chlorine has filled this empty spot with one of sodium's electrons. Okay, so now chlorine is super happy. It has a full valence shell. It's achieved its goal in life. But take a look at sodium over here. Though you may not know it, sodium has also achieved its goal in life. Because when it gave this one electron, when it gave the electron to chlorine, it totally emptied out this valence shell. Now you might think, okay, that made it even worse because now it has 8 empty spots it has to fill. But here's the thing. If you can get rid of all of the electrons in your valence shell, it's like that valence shell just disappears. Sodium doesn't even have to worry about it anymore. Okay, so it gave away this last electron in its valence shell, and now it's like the valence shell just disappears. And this is now sodium's new valence shell. And check it out. It's totally full. So by giving away that one electron, it could get rid of its whole outer shell, and this is its new valence shell. It's full, and sodium's happy. So this is what we end up with. Let me just show you what the intermediate steps look like here. And this is what it looks like when sodium gave it away, and we can sort of think about it still having this outer shell, and here is chlorine with the new electron from sodium. So we've got step 1, step 2, step 3. Okay, so now chlorine has a full valence shell. Now sodium got rid of its old valence shell, and its new valence shell is totally full. They're happy. But let's talk about what's going on with the electrons here, okay, because there are electrons moving. Now, over here with chlorine, it used to have 17 electrons, and then it got a new electron from sodium. So it doesn't have 17 electrons anymore. Now it has an extra one, so it has 18 electrons. But it has the same number of protons because we weren't moving protons in this example. Okay? So it's still got 17 protons, and it's got 18 electrons. But now there's an imbalance between the number of protons and electrons. It doesn't have the same number of protons and electrons anymore. It has more electrons, which means that it has a negative charge. It has a negative charge of 1 minus because it has one more electron that it got from sodium. And now we can call it an ion. Now, sodium also became an ion, right? It used to have 11 protons and 11 electrons, the same amount, so it used to be neutral. But not anymore, because it gave away one of those electrons, so now it only has 10. But it's still got the same number of protons. It's got 11 protons with positive charge, and it's got more protons and electrons. One more proton. And that means it's going to have a positive charge, okay? It's going to have a 1 plus net charge, and it also is going to be an ion, an atom with a charge. So this guy over here has a 1 minus charge. This guy over here has a 1 plus charge. Now, as we've said before, they have opposite charges, so we could maybe kind of zoom out a little bit. We'll take a look at what these atoms are going to look like. Here we've got a chloride with a negative charge. We've got sodium with a positive charge, and they're going to stick together, just like we've shown here. And that is because opposite charges attract. we have the positively charged sodium attaching with a negatively charged chlorine, and that's going to give us sodium chloride. Sodium chloride. Now, the formation of ionic bonds is one of the trickiest concepts in all of chemistry. So many people are confused by it. So I just want to go through this one more time, really quick, step by step. Okay, so we start out with sodium and chlorine. They are both neutral. They have the same number of protons and electrons. But they're both unhappy because their valence shells are not full. Chlorine has an empty spot, and sodium has only one electron in its valence shell. So the electron here moves from sodium to chlorine. Okay, so now chlorine has one more. It has a full valence shell, and it's happy. Sodium empties out its valence shell, so it's almost like that old valence shell just disappears. We end up with this, and the new valence shell is totally full. So now sodium and chlorine are both able to get full valence shells. But electrons had to move in this process. So now sodium has one fewer electron than proton, so it gets a 1+ charge. Chlorine got one more electron, so it has one more electron than proton, so it has a 1- charge. So these guys, they trade electrons, or an electron moves from sodium to chlorine, in order for them to get full valence shells. And it's in the process of that happening that they end up getting charges.